Hello everybody, my name is Joshua Blake and I'm coming to you from Woodbridge, Virginia, and this is the PointStreamer live show. We're going to be talking about PointStreamer, 3D video, and lots of cool stuff. Let me introduce my co-host, Gordon McShane. Hi Gordon.
Hey, it's Gordon McShane. I'm right outside of DC in Gaithersburg, joining you tonight. Got a lot of cool stuff on the docket tonight. Why don't you let them know what we're going to be talking about tonight?
Alright, so today we're going to be talking about updates to PointStreamer, what we've been working on as far as development. We're going to be talking about some things about what's possible in the future of 3D video, and also discussing how we might be able to edit point streams with the Leap Motion controller. We have some cool ideas about that. So that's what's on the topic for today.
I want to apologize. We did promise we would be back last week, but I was very sick and couldn't make it. We had actually had a pretty cool show planned, but we'll do that one soon. But Josh, you had a pretty exciting week in lieu of our show. You were off all the way across the United States.
That's right. So I was actually in Redmond visiting the Microsoft campus for the Microsoft MVP Summit. And the MVPs are community members who contribute to various communities around Microsoft products, and Microsoft has recognized them. So they don't work for Microsoft, but basically like super users, kind of. And I'm a Connect for Windows MVP, and so I had a lot of time with the Connect for Windows team and the other Connect for Windows MVPs, and had some great discussions about what's coming up for Connect for Windows. Nothing I can really talk about because it's all covered under non-disclosure, but I was basically running around to a bunch of different people and buildings, and anyone who would give me 15 minutes, I was showing them PointStreamer and doing lots of demos of PointStreamer and some of the other stuff we've been working on. And that was really cool. Got a lot of positive feedback about PointStreamer, people who are excited about it, people who get what we're trying to do and immediately latch onto it and figure out other new things. Two of the people that I knew from online, from Twitter, and had met in person for the first time last week. They're from Australia, Bronwyn Zandy and John O'Brien from Soul Solutions. I was talking to them about PointStreamer, and they said, well, you know what, we're actually going on a safari in about 3 weeks, and we want to take PointStreamer on the safari and capture various things on this, so that they're going to be visiting a habitat that has lion cubs, and they want to record the lion cubs in 3D, and I thought that was super cool. It's a great idea. So I'm excited about what they are able to come up with. And one of the issues with taking PointStreamer on the road, or taking Connect on the road in general, is the fact that you kind of have to have a plug, at least for Connect for Windows. You have to have it plugged in. And so they actually came up with a pretty cool solution that will give them a little bit more flexibility, especially when they're visiting the lion habitat. And they actually blogged about it this week. So they made a battery pack for Connect. And so they talk about it on the blog here, how they made it. And it basically looks like this. So they actually sacrificed one of their power cords and plugged in. This battery pack has 10 AA batteries, and they think that will power the Connect for several hours. So that's pretty cool.
Oh, definitely. I mean, that was one of my biggest kind of gripes with this at this point, with the whole 3D thing. It's this tiny Connect device, and it's ostensibly almost USB powered, except for the draw of the microphone. But you are kind of locked next to your PC, which might be a desktop, for power and otherwise. And now we've got laptops and a battery pack. I'm thinking we should put one together at the office and see how much battery life we can get out of it. I don't know, did they say anything about that to you?
Yeah, they said that they expected it to get about 8 hours. They haven't tested it for the full 8 hours yet, but they think that they can get about 8 hours of power out of that. I'm a little bit skeptical, but I think that it'd be really cool if they could do that. Obviously, that'll last longer than most laptop or slate
Yeah, and
batteries as
that would
well.
probably be the one peripheral that would last the longest. I mean, I have my my DSLR, my camera lasts 90 minutes, when I'm running video and stuff like that. So, I mean, 8 hours is great.
Yeah, it is. So besides talking to people in person, we actually started getting some emails from viewers of this show, our first show, the previous one, and people basically just expressing their enthusiasm, and also people who wanted to figure out how to get PointStreamer into the hands of others. So I got a pretty long email from Ellen Perlman, who's associated with the Volumetric Society in New York City. And she was very excited about getting PointStreamer into the hands of artists, and about the fact that we could, PointStreamer would let people who don't know about programming, don't know how to create their own program that does point clouds in 3D, to get started with that. So it enables a new capability for a broader set of people.
Yeah, and it's gotten us thinking about where PointStreamer fits in the workflow of your average user and your artist. And can't we originally envisioned it as sort of the end of the chain. You take video and then you load it into PointStreamer and you do your editing and your sharing in there. And then you deliver your content to whoever you want to show it to, your family, your friends. But there's another whole realm of this being almost a piece in the middle. We can you can maybe hook this up to some other piece of software that you're already using in your day-to-day, artistic. We were talking briefly about VVV or Max MSP the other day, and it'd be really interesting to integrate with those in some, you know, default kind of way, so you could bring our point data out of the application and do some really unique compositing of audio and video and cloud data.
So let's talk about what we've been up to with PointStreamer. So last week I was a little bit busy with the trip, but we've been working on the DSLR integration, being able to use external cameras and calibrate them with the Kinect so that you can map up the high quality RGB to the Kinect and use that in your point cloud. So we don't have that ready to ship yet, but it's still a work in progress. So we're going to talk a little bit about that. Before I go into there, I actually wanted to talk about one issue that some people were reporting. So it's a known issue. I wanted to make sure that everyone was aware of what the workaround is. So if you have problems installing, if the installer fails for some reason, and we've seen this on Windows 8 more often than Windows 7. So there's a workaround. It's really simple, but on our user voice site, pointstreamer.uservoice.com, we have a knowledge base article. It's down here. It says DirectX installer path issue on Windows 8. So if we go into there, and I'll zoom in a little bit. Basically, our installer is failing sometimes on Windows 8 if this directory is not created due to a permissions issue. So the workaround is to create that directory, C temp DirectX, and then run the installer again, and then you should be good to go. But please let us know if that doesn't work or if you have any other issues with the installer. All right, so besides that, Gordon, can you tell us a little bit about how the DSLR takes advantage of infrared, the DSLR calibration process?
Sure. Can you go ahead and start that? I'm actually about to post a link for everyone dealing with
Okay.
that issue, so they don't have to.
All right. So basically, when you have if you're trying to do high quality video, you're limited by the resolution of the Kinect RGB sensor, which is not HD. It maxes out at 1280 by 960 at 12 frames per second. Or if you want to make sure you have 30 frames per second, then you need to have it running at 640 by 480. So that doesn't get you a lot of resolution, but it works fairly well for a lot of things. So we use an external camera. We're working on a process to calibrate your external camera to your Kinect. And one of the features that we are taking advantage of is the infrared camera. So the depth camera of Kinect comes in through an infrared sensor. That's the rightmost hole as you're facing the Kinect. And let me actually grab it here, and I can show you. So the infrared camera, which is right here, we actually want to understand the relationship between that camera and your external camera, whether it's a DSLR or a GoPro or an HD webcam. And so there's a little bit of a process, and we're figuring out ways to improve and streamline it. But I want to show you a little bit about what that involves. So let me set this back over here.
It's helpful to understand more about your Kinect, I think, and I'm glad we're doing this because there are a lot of things that when I started using the Kinect, I didn't really understand. For instance, that there was an infrared projector in there, and what the process was behind it, and how how it actually achieved what it achieves. And you can sidestep a lot of painful blackout areas or reflections or in your just in your scenes just by understanding how the infrared sensor works.
So yeah, that's a good point, that we should try to understand our hardware a bit better, and that goes for anything in general. So I'm going to share my screen here, and I'm actually running what's called the Kinect Explorer, and this is a sample application that comes with the Kinect SDK. So if you're a developer, you're probably aware of this if you're using the Kinect for Windows SDK. So I have the Kinect running over here to the left of my regular camera I was using. You can see we have the RGB on this screen, the depth data here, and I'm actually pretty close, so it's part of it's too close. But we can also change the mode for the color camera from the color stream to the infrared stream. So let me show you what that looks like. So this is actually the raw view of what the infrared sensor, the one I was pointing to earlier, what that looks like before it converts into depth values. So the infrared projector, the leftmost opening that projects these infrared dots out into the scene, you can see them all over the place here. And the Kinect internally translates the offsets of those dots, the little dot patterns it can recognize, translates those into depth values. We actually want to use the infrared view without the dot pattern, so without depth for a moment, in order to discover what the relationship between the infrared camera and the external camera is. So the way we can do that is by using a special calibration pattern. And so the kind of industry standard is using this chessboard pattern with OpenCV, and you would run a program, not this program, but you'd run a program that knows about the chessboard and can recognize the chessboard as it moves around. And since it's a known physical thing, then it can figure out what's the relationship between this chessboard and the one camera. And if you have two cameras looking at this, so both the external camera and the Kinect, then you can actually discover the relationship between both of those cameras just by the fact they both can see this chessboard. And you actually need to have several photos, maybe 9 or 10, using this procedure in different orientations in order to fully discover the relationships. And so there's a lot of math behind it, and I'm skipping all of the math.
It, the way I like to think of it is if you can imagine the lens of a camera, it's in order to focus the light, it's slightly curved, and each lens has a different curvature. So what we actually see, those squares on that chessboard aren't going to actually be square. They're going to be slightly distorted by just the fact that the lens is curved. So what we do is we go in there and we figure out how do we make those squares flat. And we figure out how to do that for both cameras, and then we both have the flat squares, and we can convert between the different distorted squares, to get the appropriate images for both.
Right. So once you undistort it, you can map the image from the external camera onto your depth image, because the depth image is taken from the same perspective. Notice if I switch back and forth between the depth and the infrared, it's basically aligned perfectly. So we can map the high resolution HD RGB onto your depth image. So we actually have to turn off the infrared emitter. So you can, when you get close, the dots kind of wash out. They're close together, and that's why sometimes when things are too close to the connect, it can't see depth because it can't recognize the individual dot patterns. But when you put something, in this case, when we're looking at the infrared view, it's kind of illuminating the whole thing. However, when it's far away, it doesn't work very well because it's not enough infrared illumination across the entire chessboard to recognize. So we can actually turn off the infrared emitter using a switch in the SDK. So our program, PointStreamer, or other people's programs can turn off the infrared emitter. And so there's very low levels of infrared light right now, and I have an incandescent bulb that has a little bit of infrared, so you can kind of see that there. I also have this. Let me turn this back on for 1 second. So I also have this kind of key fob that has infrared. This is kind of good for debugging. This is an infrared LED. So when I look at it, I only see a very very faint red glow. But when the Kinect looks at it, it's very bright, so kind of shining it in at the Kinect's eyes because it's infrared. So when I turn off the infrared emitter, I can actually use that to light up the whole scene, get more constant illumination, and the program can recognize the chessboard. Now, in the end, I'm not suggesting, like you can get kind of a spooky glow here. I'm not suggesting that we go around with manually holding these things. We're working on a better procedure. Maybe it involves an infrared floodlight that you might get online for $10 or $20. Normally used for night vision cameras, which use the low-level infrared lights. And we're working on can we make this chessboard procedure easier? Can we actually eliminate the chessboard and have some type of automatic calibration? And we also talked about last week the mount between the Kinect and the external camera, that we actually want to work on the mount so that it's easier to mount it. You have the quick release so that you can do the calibration once and pack up the camera and put it back on without having to redo the calibration, having to redo the example.
So what that does for you after this is all said and done is you get amazing looking videos. I mean, it's just, and we talked a little bit about this before in the last video. I don't want to cover the same ground, but the level 640 by 480 will be pushed up to 1080 or 1920 by 1080, or effectively what you see on your HD TVs these days. So, with the camera that I have personally, it's a nice DSLR. It's not extravagant by any stretch of the imagination, but they use that camera, for instance, on a season of House, that show on Fox, and if those guys can get away and make art with that, then so can we. And I'm just saying, where I think there's going to be some pretty amazing stuff coming out.
Yeah, so we're excited to add this to PointStreamer and see what people are able to come up with. So that's basically what we're working on right now. We're working on the DSLR. We're also working on that installer issue. We're going to try to get that taken care of and put out a new release hopefully sometime soon. One other thing we should mention is we want to integrate with the most popular APIs for DSLR. So Canon and Nikon both publish an SDK for the cameras. So you can plug the camera in with a USB cable and plug that into your computer, and then your computer can control it. So it's a remote shutter release and control other parameters of the camera. So we want to integrate with that so that all you have to do in PointStreamer, if you want to make a recording, is push record in the application, and then it automatically starts recording with Connect and starts recording with the external camera, whatever external camera you happen to be using, and then copies the files over automatically and basically takes care of all the stuff that needs to be done behind the scenes as much as possible, and makes it super easy to get started with this. So that's the direction that we're heading. We're not quite ready to release that feature or a new update with that yet, but that's the direction we're heading.
Yeah, we reached out to both Canon and Nikon, and so InfoStrat, PointStreamer, the company that develops PointStreamer, that we're part of, is now developers for Canon and Nikon. So it's exciting. I'm working on Canon, and Josh is working on Nikon, and they're both actually pretty nice APIs. They allow you to get pretty deep within the camera, you know, changing all sorts of settings. So we should be able to automate a fair bit of this process.
So now we've talked about PointStreamer, what we worked on. We actually want to have a little bit of discussion about what's possible with the future 3D video. And to figure out what is going to happen in the future, a lot of times it's easy to look back to see what's happened in the past, what's the history of these things. So there's a couple things that we want to bring up to talk about, or to give some context to what we're doing and what the trends we're trying to plug into. So I actually want to show a short clip of Bruce Sterling at the Vimeo Festival and Awards in 2010. And he was talking about, so Bruce Sterling is a futurist and a speaker and novelist, and he was talking about in 25 years, what will the cameras in 25 years maybe be able to do? And so let me pull that up. And it would be nice if you guys could hear it. So I'll go ahead and enable that here.
Feels black and white camera of the Dick Van Dyke Show days. Well, they would look something like this microphone, except probably a lot smaller. And this thing here, the head of the microphone, would be the lens, except it's not a lens. It's just a piece of black fabric or glass. It's an absorptive surface that simply absorbs every photon that touches it from any angle. And then in order to take a picture, I simply tell the system to calculate what that picture would have looked like from that angle at that moment. You see? I just send it as a computational problem out into the cloud wirelessly. It's like, you know, the gentleman up here who's wearing the HF shirt, you know, and the gray shirt. You know, I saw him back there, and I would really like to have a close-up picture of him. In fact, I'd like to have just a picture of every expression on his face during the hour that he watched me as I had my camera there. And that action would take maybe 40 seconds of processing time, and then the thing would arrive packaged, and you would just be able to use it. In other words, there's sort of no camera there. There's just the cloud and computation. And, you know, how could I do that? Well, you know, I need a lot of computational power, sort of like tons of computational power. How am I supposed to get all that? It's cheap. That's how you get it. It's Moore's Law cheap 25 years from now. Average laptop computer, should such a thing exist, something like 2048 at today's computers. 2048, what can I do with 2048 video cameras packed down into a single thing? And I don't even have to do it within the machine. I can just offshore it and have Google figure it out for me. So what happens to media under a circumstance of that kind? There isn't any. Media is a medium, right? It's like you're here and I'm there and there's like something in the middle and I transmit it to you. There isn't any such thing there. We're just in a reality that happens to be kind of visually augmented, and I could just basically pull anything I want. In fact, if I want a picture of the back of your head, I just have the system calculate it. I mean, it knows everything in the world, and it simply simulates a picture of the back of your head. It knows what the back of your head looks like because you turned around over there, and it just sort of goes in and post and fixes the picture and brings it up and puts it on there. And I thought, oh, well, that's not a real picture. It's just a simulated picture. I can't tell the difference. I don't care.
So I'm going to stop that right there. But basically, he was talking about what's possible in 25 years, possibly. And we're actually not that far off from that kind of thing. So there's actually something, a device that was released last year that just sort of like that. And so, Gordon, if you can talk about that a little bit.
The device he's talking about is the Litro. It's a light field camera, and you may have heard of it, you may not have, but it's not quite as powerful as Bruce Sterling's imaginary device, but it's pretty amazing. It's got basically what it does is you take a picture with it, and it captures all of the photons that come into the camera at that instant. Instead of refocusing it through an aperture, it just captures them all. And that allows you basically, after the fact, to go back and refocus to any depth of field that you'd like. And at the same time, they're also working on the ability to get a marginal amount of three-dimensionality out of it as well, because it's captured most of the photons, in a certain degree spectrum of that of the camera. So it's we're getting there, And the Kinect is a similar device in that it captures a lot of information across time rather than across the light spectrums. So they're almost analogous in a way. We can do things with the superfluous is not the best word, but the large amount of information that we capture. Can you think of anything else about that that's worth mentioning, Josh?
So yeah, I just wanted to show what the Litro camera looks like. So it's this box-shaped camera, and as Gordon said, it basically captures all the photons from all the directions, just like Bruce Sterling was talking about. And they have a little gallery set up here, and you can actually go in and choose a picture. So I'll just choose one of these, and they have a little web viewer that loads up the information. And because you have all the photons from all the different directions, you can actually refocus the camera. So I can click here and it's going to focus on this foreground object, or click back here and it focuses on the background object. And I'll try to, here's one with a person in it. So the boy's in focus, and I click back here and the gingerbread man and the girl's in focus. And you can actually click and move around. It has a little bit of 3D, within the size of the light field. So this is on the web. This is in Chrome and works now, but it's just a static photo. So I wanted to actually show we're doing something similar in PointStreamer right now. So let me pull up PointStreamer here. And so this is PointStreamer, and I'm showing this in here. And I'm actually going to pull up an existing recording. So this is the Welcome to PointStreamer sample recording that you can download from PointStreamer.com. And so we can play this back, and I've muted the audio, but it seems like whenever I pause it, I always have my eyes closed. So one of the things we can do, if we open up the settings menu, we can enable the depth of field effect. So we can say we want to have the focus to be on the foreground or on the background. Let me back out a little bit. So we can say, well, after the fact, after we've captured it, in addition to choosing what we want to be the composition of the scene, do we want to have a near shot or a far shot? We can do all that in post. We can also refocus this, apply different kinds of rendering effects. And we can also do the same thing if we remove the background and take person from this scene and put it into a different scene. So that's something that we're working on. We're working on cool effects like that that are enabled by having all the data available in order to recompute what would be what the image would look like if you had taken this photograph or video from a particular angle with a particular camera settings. So we're getting there. We're getting to where he was talking about. So there's actually another quote. This was a recent thing. So a photographer was talking about photographer Clayton Cubitt. He was talking about the future of photography, and so he was talking about suppose you had always on 360-degree HD cameras everywhere, and what would happen if you had that? And basically the idea that he was talking about was, if you had that situation, then the photographer is not so much the one that sets up the shot, but the role actually morphs into a curator of reality. So that's the quote, the curator of reality after the fact. So just like with high-speed footage, when the photographer sees something interesting, they might push a button that will just flag the data stream that says this is something interesting out of all the data that's coming in, and then go back after the fact and figure out what's the best way to present it, what's the best way to composite different data sources together. And he actually mentioned, maybe mentioned additional cameras. Maybe it's something like 3D LiDAR, which is an older 3D scanning technology using lasers rather than infrared dots. So it's similar to Kinect. It's a 3D scanner. But this is not science fiction. It's not something that's far off. This is something that it's sort of possible today, and we're getting there. But I think it's interesting the changes that we have to realize about creating and expressing ourselves with these new possibilities.
Yeah, if you look at it from the wrong perspective, it's a little un-zen. You're going from celebrating impermanence to now everything is available. All angles and everything, and you're no longer a person who's capturing a single event. You have all the events, and you can look at any of them at any one time. So I think it's going to take a little bit of getting used to, just in cultural and in general. But the options are amazing. The fact that you could shoot a movie and then rework it 100 times and it being different. I guess that is kind of zen, right? I mean, you don't have to be too attached to any one thing.
Yeah, you kind of go with the flow and see what you can express. So there's actually there's a really good example. So those of us who deal with Connect and do Connect things, people always think of oh, that's like Minority Report. That's the cultural example of next generation interfaces. There's actually kind of a similar thing for 3D video. A lot of times when we describe what we're working on, someone will say, "Oh, well, that's really like the House of Cards video that Radiohead did." And so Radiohead, they created a music video that they used a LiDAR and some other effects to create a point cloud and render that point cloud in 3D. And I'm going to skip around a little bit here. And so that's part of the aesthetic of the video.
And you have to remember, this was in 2007 or 2008. So it's been 5 years probably since they did it. It's pretty amazing back then, and pretty amazing that it sort of, I think, it was almost, the only way I can describe it was before its time, basically. That's what I'm trying to say.
So the interesting thing that Radiohead did was they didn't just make the video. They actually took the video and published the raw data. And they said, you can take this raw data, all the raw 3D points, and do whatever you want with it. So people actually took that and created their own renderers. So instead of just the one presentation of Radiohead's music video, other people created cool things. This person made a strange attractor, representation of the same data, and reimagined what it would be like if they rendered it differently. And so you can kind of see parts of the original and then other interpretations. This other hack was kind of this was a WebGL viewer. So actually, this can run in Firefox or in Chrome using WebGL, and the person watching this on the web could move their mouse around and change how change the virtual camera angle and change the presentation of it.
And you can if the information, then you can still download it. It's on Google Code, and I think they give you about a minute and a half of the data. They don't give you the audio. They don't give you. They just give you the point information. No color, no RGB, and it's nearly. I think it's nearly 400 megabytes compressed. And it's one of the things that PointStreamer really excels at that most other products or softwares on the market right now can't compare to us in. We can compress that 3D data incredibly well. We've gotten to the point where the stream that we're sending from PointStreamer to somebody else's computer is roughly HD video. So you've got 640 by 480, so you get 480p plus audio plus depth data coming down at roughly HD, what it would take to stream a movie to your living room, basically. And we're working actively to improve that as well. We think we've got some ideas how to increase that even more. So that's one of the things that most products out there, I can't be sure, but I think we're the only product out there that has that feature.
Yeah, that's one of the things that we're most proud of is making it practical to take the large amount of data and do things on the internet. So the web viewer that we were talking about for the House of Cards was relatively low resolution, but we wanted to enable it to be much higher resolution and let you upload your point streams at some point to PointStreamer.com, be kind of like the YouTube of 3D video. And so people on the web could just take that, move the cameras around, and if you allow it, download your point stream, your recording, and remix it and create new works of creativity with what you've created. So eventually you could think of a situation where you would go to PointStreamer.com and search for cats and find all the videos that have cats in them, download them and extract out the cat object, and move them around in your own set, a virtual set of some type, you have them kind of flying around or walking up the walls or other cool things like that.
Sometimes I think you went to school and studied math and computational geometry just so you could develop something that could compile all of the cats and put them in some 3D environment.
Yeah, that's one of the things the internet's for, is for sharing cat videos and cat pictures. So that's one of the end goals, having the web viewer, but as an end result of what you do with your recording. But we also want to enable people who they have their own stacks, the artists or others that are using Blender or VVV or other 3D applications or 2D applications, to integrate that into export their point stream into a format that they can use in other programs and create something outside of just PointStreamer. So we want to have interoperability about that, and that's one of the things that people have sent feedback to us about, and we are definitely listening about that.
Yeah, we've already seen what some of the people who have been doing stuff with Max and how they plan on. Max is a cycling 74 product. It's like VVVV. It's almost like, if you guys don't know what that is, they're both very cool products that allow you to accomplish some rather amazing programming tasks that you usually would have to get pretty dirty in the code to do, but you can use a graphical user interface. You can almost do it like you're putting together a set of pipes in the plumbing system. And we've already seen some point cloud stuff, and we're just excited to add our identity to those products too, to see what people can do.
So moving along, I promised that we would talk about the Leap motion sensor and some ideas we had for that. And people were asking us, are you going to integrate Leap motion? Are you going to integrate Oculus Rift, which is kind of a VR goggles setup? And so last week when I was talking to the MVPs and the Microsoft folks, we actually were talking about Leap, and we said, well, some people were asking, what is the Leap motion good for? And what can it do that is better than just using a touchscreen or just using mouse and keyboard, or just Connect? So I actually want to take a moment to explain what Leap is, and I'm actually going to move the camera around, so bear with me for a moment while I try to show you what I'm doing. It works better with the camera than as a screen share, and then talk a little bit about how we want to use that in PointStreamer. So the Leap motion device is this small device. So I'm going to take us mobile here for a minute. So if we look right here, it's this small device that it also uses infrared, so it's visible on the webcam, but I can't see that. And it connects to the computer with USB, and it creates a small area where you have motion tracking. So it's much smaller than Kinect, but it's also higher fidelity, and they've designed it so that you can work with it really well with your hands. And so I'm going to try to show what this looks like. So I'm going to show you my hands, and on the screen you can kind of see, so I'm just hovering my hands over here. You can see these streams, these trails. So one for each finger, and I put one finger out, or two, or four. So basically it can track it in 3D, just like Kinect tracks a person in 3D. But this is on a much smaller scale. So one of the advantages of this is that the ergonomics work pretty well. That normally you might spend all day using your mouse like this, resting your hand on the desk and moving around, making small muscle movements. Well, the Leap is the same, except you rest your arm on the desk and your hands above it. You use relatively small muscle movements to do 3D input. So this is something that you could do for a while, and you don't have the gorilla arm problem, the problem of getting fatigued after using it for a period of time. And so the next question is, with the Leap, what is the target use for it? So where is it best? Everything is best at something, and worse is something else. So what is the Leap motion best at? And so when we were discussing last week, we said that the Leap is great for things that have native 3D content. So one example would be a CAD program. You can reach into the program in 3D and grab something, or you use different hand postures and gestures to do different actions to manipulate or morph a mesh. And for us, so I'm going to put the camera back here. For us, with PointStreamer, we also have native 3D content, and so we were thinking about how can we take advantage of the Leap motion or other similar sensors. And we thought how cool it would be and how intuitive would it be if you wanted to change the virtual camera and you know, puppeteer the virtual camera, sort of. So maybe you have a recording and you want to choose the best way to present the virtual camera. What if you could, say, move the camera in real time and record the camera track by moving your hand around and push in and then pull back and then use different effects. So maybe one hand is doing the depth of field effect, and the other hand is controlling the 6 degrees of freedom position of the camera. So that's something that we think would be really excellent use of the Leap motion sensor. And so we're planning to, maybe not in the final production version, and we need to test it out and see what people think, but at least have a prototype example of using Leap motion with PointStreamer. So we're going to be putting that out when it's ready. You know, no promises on dates, but that's something that we're thinking about.
Yeah, and I just recently got I guess, one of the latest and almost final batches of the Leap, and I've been using it, and so far it lives up to the hype. So yeah, like Josh says, we're really excited to try it, because you know, you should definitely go to the website and check out the video, because it's pretty honest, I would say. You can definitely get in there and track all of your fingers and do very fine motor skills. So, not endorsing them, but I think they've done well for themselves.
So we've actually gone a little bit long, but maybe that makes up for last week. We kind of put 2 weeks of content into 1 week. So you know, maybe
Thanks
that's
for
okay.
sticking around.
Yeah, thanks for watching here. We hope it was interesting. So to wrap up, if you have any questions for us, you can email us at pointstreamer@infostrat.com, or you can go to the PointStreamer website and click on the feedback widget, type in your question or problem, or if you click on, once you log in, you get this, get the links here. You can say vote for feature ideas, and this takes you to the feedback page on user voice. See what other people are voting on. Put in your own ideas. So let us know what you think, and what you'd like us to add the most. If something in particular we talked about in the show is really interesting to you, let us know so that we know. And if you have any questions or things that you'd like us to cover in future shows, also let us know. So
Yeah, I was just gonna say, you know, when you contact us, you're either talking to Josh or me. We're the two guys currently behind this. We'd love to add more people to the team when the time is right, but currently it's just us two. So we generally need you guys to come out and tell us where to go next. So do go to the user voice, so we can put the resources in our time where it most benefits you. And yeah, you'll definitely have any questions, talk directly to us.
So we appreciate your time and want to thank you for attending this week's PointStreamer live show. If you haven't tried a PointStreamer, go to PointStreamer.com and download it, check it out, and we hope to see you guys next week. Thanks.